Tonight's video lesson is on section 3.5, where it crosses, determining y-intercepts from various representations. So in the previous lessons, we were talking about the rate of change and figuring out how to come up with the rate of change using tables, graphs, and in a context of a situation or a problem. Now we're going to be doing the same thing, except this time we're going through and finding the y-intercepts. To start off tonight, I'm going to have you turn to page 186, and you're going to complete numbers 1 and 2. Only numbers 1 and 2, and then you're going to press play. So number 1 says to read the context, and that's on page 187. You're going to read over the context part, which is in the upper left-hand corner, and then you're going to represent the information from the context box into the other 3 boxes. So you're going to put the stuff that's in the context box into the graph box, the table box, and the equation box. Then you're going to revisit each of them and show what the rate of change is, or how it's represented. So just do numbers 1 and 2, and then press play when you are done. After number 2, your book says the rate of change is one important feature on a linear function. And a linear function, if you don't know, is basically just what you had graphed on page 187. So it's basically just a line graphed on a graph. Another important feature is the y-intercept. The y-intercept is the y-coordinate of the point where the graph crosses the y-axis. So in the table, or on the graph that you had just graphed, it shows that your line crosses the y-axis at about 60. Okay, so the y-axis is always, I can get out its pin. The y-axis is always on this left-hand side over here. So it's whenever your line crosses this point. It also says that the y-intercept can be written in the form of 0y, and that's going to be important to remember. It's whenever your x value, or across the bottom, is equal to 0. That's why it happens to fall along the y-axis. So for example, if we are starting out 5 miles away from home at a gas station, and we're going to drive home, if we travel for 0 mile or minutes, whoopsies, I was going to try and write with that. That's not going to happen. Okay, if I travel for 0 minutes, I'm still 5 miles away from home. So I'm up here at the 5 mark, even though I've traveled 0 miles. Or 0 minutes. Sorry, I keep saying miles. So even though I've traveled for 0 minutes, I'm still 5 miles away because I'm at the gas station that's 5 miles down the road. Okay, so my x value would be 0 because I haven't taken the time to drive anywhere yet. And then my y value would be at 5 because I'm still 5 miles away. Okay, now you're going to go ahead and finish up numbers 3 through 5 on page 186. When you're done with that, you can go ahead and press play again. All right, I'm going to go ahead and move on to problem number 2. Again, we are determining the y-intercept from 3 different types of problems. We're going to use graphs, we're going to use charts, and then we're going to also use the context or the story problem type. So here it wants you to examine each linear graph and determine what the y-intercept is. Write the y-intercept in coordinate form and show all of your work. This graph is nice and easy. All we have to do is go over 0 on our x-axis and follow it up until we hit the line. And here we're hitting the line right at about 4.5. So that would be, again, over 0, up 4.5. However, if you look down at your next graph, that's not so easy because you can't see where your line exactly hits 0. So I'm going to show you on number 1 how we would have found that out had we been trying it without being able to see it so easily. Okay, so I have 2 points that meet very nicely on the axes, or meet nicely in between the points. I have 0, 6, and I have 2, 3. So what I'm going to do is I'm going to figure out the spaces between them. I'm going to go backwards 1, 2, 3, 4, and I'm going to go up 1, 2, 3. So each time I'm going to make a new dot on my line, I'm going to go backwards 4 and up 3. Since I can see that my point 2, 3 doesn't get me far enough over to the 0 line mark, I'm going to take my points back 4 and up 3 more. So if I go back 4, that's minus 4 on my x-axis, and remember plus 3 or up 3 on my y-axis. 2 minus 4 is negative 2, and 3 plus 3 is 6. So I know that that point's going to be over here at negative 2 up 6. So that point's going to be right about here. And it fits nicely in with my line. Now I need to figure out where it hits the y-axis. It's going to be halfway in between those 2 points. So what's halfway between 2 and negative 2? Well, if I plot them on a number line, I start at negative 2 and I'm going to go in 1, 2, and I'm also from 2, I'm going to go into 1, 2. We find that 0 is right there in the middle. If I do the same thing with what's between 3 and 6, I'm going to go in 1 from 6, I'm going to go in 1 from 3, and I still need to find what is directly in between 4 and 5, and I should get the answer of 4.5 here in the middle. So then I know that my point where the axis is hit on the y-axis is at 0, 4.5. And that goes along with what I could easily see because this graph was an easy one. I want you to go ahead and try number 2 and press play when you're done. Here's your answer to number 2. Again, it was a little bit tricky because it wasn't easy to see on your graph. Your graph wasn't big enough to go all the way back to the y-axis hitting, or the x-axis hitting 0. So you should have gotten an answer of 0, 115, which means it would have hit way up at the top at 115. If you have questions or if you're struggling with how to find that, I know this one's a little bit more difficult, please make sure you circle it or highlight it or do whatever you need to remember to ask questions about this one in class. But I'll make sure we go over it so that you get all your questions answered. Okay, moving on to the next page. Each table represents a linear function. Again, that's just a line on a graph. Use the table to identify the y-intercept. Write the y-intercept in coordinate form and show all of your work. We need to pay attention to what this girl is saying over here on the right. She says, so if the y-intercept was given in any table, would the x value be 0 or the y value be 0? And if we remember back when we were writing all for the graphs, when we were finding the y-intercept, we always had over 0 up some number, which would be our y value. So the x value is 0 because, again, when you have your graph, you want to be ending up on this y-axis, which means you can't go over on your x-axis. We have to stay at 0, and then we can go up or down as many as we need. Okay, so your x-axis is always going to be 0. Okay, just had to give myself some room. Here we notice on our graph that we are counting up by 25s. I need to work backwards and count down by 25s until, again, I want my x value to be 0. So I'm going to go to 175, 150, 125, 100, 75, 50, 25, 0. And I'm going to notice that I counted backwards 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I forgot my comma there. 8 times. That means on my y-axis, I'm going to want to do the same, and I'm going to want to count backwards 8 times, except I need to be careful because on my y side, I'm counting backwards by 2s. So I've got 14, 12, 10, 8, 6, 2, 0, and negative 2. That should be a 0 comma if you're confused. So again, let me check my work. 1, 2, 3, 4, 5, 6, 7, 8 times. That means when my x is 0, my y is going to be negative 2. And there it is written in the ordered pair. Try number 2 on your own. When you're done, press play to check your answer. Here's your answer to number 2. You should have gotten the ordered pair of 0, 90. Again, they were counting backwards. Your x values were counting backwards by 5, and your y values were counting back by 4. And then you had to make sure that you counted back 20 times on each side. So again, if you have questions, circle it, highlight it, put a star by it. Let me know in class tomorrow. All right, the last example I'm going to do tonight is from working through a context. Again, they want you to write the y-intercept in coordinate form. Let me get my pen ready. Kim spent $18 to purchase a ride-all-day pass at amusement park and to play 8 games. So $18 for the pass and to play 8 games. After paying a total of 20 games, she realized that she had spent $24. So Kim, in all, spent $6 to play the games. Because I'm taking the $24 that she spent total, and I'm going to subtract off the 18 that was for the all-day pass and the 8 games. That also means I need to take the 20 games that she played and subtract off the ones that she's already paid for, because she paid with these in the $18 pass deal. So that means she paid $6 for 12 games. Again, I'm taking her total amount that she paid, and I'm going to subtract off the deal price of $18. So she paid a total of $6 extra, and 20 games total minus the 8 games that were prepaid in this 18 means she paid $6 for 12 games. A little bit confusing, I know. Then I'm going to kind of work backwards, and I'm going to figure out that she paid 50 cents per game. And if she would have played the 8 games, that would have been $4, because 50 cents times 8 games is $4 for the 8 games. So if I take the original price of $18 and I subtract off the $4 for the games, I get a total of $14. So if she played 0 games, it cost her $14. So that would be your y-intercept. So again, here's your coordinate. Here's games, and here's dollars. Okay, the amount of money she spends depends on how many games. So we want to find out when she plays 0 games, how much money does she spend? And here we found out that it was about $14. So if you need to go back and kind of replay what I just explained, you might want to do that. I know that it was kind of confusing, but for those of you that know what's going on, I'm just going to keep continuing. But again, that's the cool thing about the video. Go back and replay what I had just explained if you're confused. Okay, if you're ready to move on, then you can go ahead and try number 2. When you're done with number 2, press play and I'll get you your answer. Here is your answer for number 2. You should have found that it was $113 for gifts prior to saving his allowance. Okay, really read over the steps that the book took in order to solve this problem to make sure that you're understanding it. If you're completely good and you completely understand, you're done for the night and you can stop now. If you read it over a few times and have replayed the video a few times and you're still confused, please make sure you ask those questions in class tomorrow. All right, so I'm going to stop now. You're good for the night, and please bring all of your questions with you tomorrow. Have a great night.